Hey everyone, and welcome to Dr. Abu RTN Academy channel. Today we are going to discuss part 2 of the biostatistics, which talking about sets, probability, axioms, conditional probability, and independent events. And in this page we are going to start with the set definition. The definition of the sets, as we can see here, set is a collection of elements that are usually related. It is not mandatory that they will be related, but usually they are related. There is a relation between them. It could be all the even number, all the odd numbers, 2x plus 1, the animals, the plants, the body organs. So some type of relation could be between them. So set is a collection of elements, number of elements, and we have to put them between the set symbol, which is 2 brackets. Okay, you can put it in shape as you like, but this is try to make this shape. If it is not possible, try as much as possible to be similar to this shape. This is the shape of the set. So the set could be containing numbers, as we said, could be words, could be pictures, could be any other things, animals, body organs, etc. Okay, as per Debrecen's PDF files, which has been given as part 2, the definition of set is a collection of definite, distinct objects. So here it is definite, so it is not indefinite. We have a definite number of objects or elements there within the set brackets or within the sets, okay? And they are distinct. So maybe they have relation, maybe they don't have relation. The objects or the elements that constitute the sets are called elements of the sets. So the objects, which is body organs, numbers, word, pictures, whatever, these objects are called elements. So each number or each figure or each whatever here, each one of those are called elements. So all these elements together, they are called the elements of the sets. Okay, so let us take an example on the sets. Okay, so in this example, as we can see here, we have set A, and usually when we write the set, for example, we write set A and I want to talk about it, I put these 2 dots. Okay, then I open the parentheses or the brackets, okay, and write the elements A, B, for example, C, D, E, whatever, F, and then close the parentheses or the bracket, the set bracket. Okay, so this is the way we are writing the set. So set A, we want to divide it, we put these 2 dots, then we can open the parentheses or open the brackets, and then write the element, this one element, second element, third element, fourth element, and so on, and then at the end close the bracket. So in this example, set A will have 5 letters, alphabetical letter, A, B, C, D, E. Could be numbers, could be months, could be object, could be organs, could be anything. Okay, so here we have 5 letters. Set B, the set B which we have here, has 5 elements, 1, 2, 3, 4, 5. But these are not alphabetical letters. It is 5 months, the names of the months. So January, February, March, April, May. Okay, so set B has 5 elements and set A has 5 elements. If they have the same number of the element, regardless what are the objects or the elements which they are in, each of them, so they're called equivalent sets. So these 2 sets are equivalent sets. Why equivalent sets? Because they have the same number of elements inside each set. So we have to distinguish between equal and equivalent. Equal set, they must have exactly the same. We'll come to this in the next example, how to distinguish between equivalent and equal sets. So as we can see here, the first set which we have, how we know it is a set? From the parentheses, from the brackets which we have here. So the first set which we have has how many elements? 1, 2, 3, 4. The second set has 1, 2, 3, 4, 5, 6. So we cannot say that these sets are equivalent, because here we have 6 elements, and here we have only 4 elements. So they are not equivalent, and of course they are not equal, because equal means that they must have the same element and the same number, the same elements exactly and the same number, so both are the same. The only difference could be the arrangement, the order of the element within the brackets. Okay, so here in the next example we'll know what is the equal set. So if we look at these two sets which we have, these two sets are equal. How we can know if they are equal or no? These two sets are equal. So if we look at the definition of the equal sets, two sets that have exact element, the exact elements. Okay, so all the elements in one set should be existing in the other set. Here we have 4, we should have the same 4. We could have end up with 1, 3, 5, 7, and here 1, 3, 5, 7, 9. So all the elements here exist here, but in this case they will not be equal because we have one element here. If they are, for example, 7, 5, 3, 1, and here we have 9, for example, so they will not be equal because we have 9 which doesn't exist here. So it doesn't mean that only these elements must exist here. No, they should be the same. Okay, so two sets, we are saying that they are equal if they have the exactly the same elements, no more, no less. The only thing, their order doesn't matter. So here 1, 3, 5, 7, and here I have 1, 3, 5, 7, but in different orders. So this start with 7, 5, 3, 1, it doesn't matter. And here, this is the brackets of the sets. So the order doesn't matter, but they must have the same element. In this case, we can say they are equal. Okay, but if we looked at the equivalent sets, if you remember, we said only the number of the element. If they have any 4 numbers, for example, the sets are equal because exactly the same number of elements and the same element themselves. But I put here 13, 11, 9, 2, for example, and this set which is 7, 5, 3, 1. Okay, these two sets are equivalent, but they're not equal. Equivalent because this one has 4 elements and this one has 4 elements, so they are equivalent, but they're not equal because the elements here is different than the elements here. Okay, I hope this clears the difference between equivalent and equal sets. Okay, the same example which we can take here, if we have January, March, May, November, we can have also an equal set which is March, start with March, January, May, November. So here we started with March, but here we started with March, and here March came as a second. January was the second here, but it was the first year. But still we have the same number 1, 2, 3, 4, 1, 2, 3, 4, and the order only changed. The same elements here are here. March is here, January here and there, May also here and there, November here and there. But the only thing that the order it changed. Okay, I hope also this clarify this equal sets. It is also worth to mention that we could have a set which in this form 1, 2, 3, 4, 5, 6 and ellipses, dots, and then we close the bracket or the parentheses of the sets. So in this case, if we have this ellipses, this means that we have indefinite number of items which is going to be continuing. So this is called indefinite set which can go to up to infinity. Okay, there are some notations which we are going to learn now about the sets and how to use them. So one of the notations which we are going to learn is this notation, which we can use it to say that A is an element of A capital. So A small is an element of A capital. Okay, so A small is an element of the set which called A capital. Let us take an example to make it more simple and clear. If I have a set A capital equals 1, 3, 5, 7, and 9. So I can say that the element, it has how many elements? It has all these elements. So I can say that the 1 as an element, 3, 5, 7, or 9, 5 elements, any of them is an element of the set A. I can say A element of, okay. So I can say 1 is element of set A. So when I use this belongs to or element of simple or notation, I'm talking about an element to a set. Element to a set, not set to a set. In the same way, I can say also here that, okay, 3 is an element of A, the set A, because 3 is here. So it is true. I can say 5 is an element of A or belongs to A. And the same for 7, the same for 9 as well. So if I have elements and I want to say only this individual element belongs to this set or it is element of this sets, I have to use this notation. So this notation means an element, which is A small, we'll call it here in this example A small, is an element of or belongs to a set. Element to set, we use this symbol. So we have to remember this carefully because we will come to know that if we are talking about set to set A to set B, we cannot use this elements of or belongs to. We have to use subset. Okay? Subset. So there's a difference between element of or belongs to and subset. So this is called let's write it here. Subset. And this one, element of. So subset, the simple elements of or belongs to this L. This notation. Okay? Okay. So, for example, if I set A countries of Europe and I close the sets. So if I said Hungary is one element or one country of this set. So I can say Hungary elements of Europe or A, set A, because set A is the country of Europe. I can say Egypt set of A, right? No, it's not right because Egypt is not a European country. So I have to put cross like this, one line like that. This line means it is not. So Egypt is not an element of set A, which is European country. This means that if I write the 26 countries here, I will not find this element, one of the 26 countries. So it is not. So the reason I put this dash here or this line here, that or this slash, I'm saying that Egypt is not an element of the set A. So because it is not an element here. Okay. If I said this is the country, if I said Budapest, let us erase this so it will be clear. Okay. I write here Budapest, element of or belongs to A. Is it right? No, it is wrong. Why? It is a European country, yes. But here we are talking about countries. Budapest is a capital, one capital city of Hungary, but it is not a country. So I cannot use it. So we have to be careful. Could be many reasons that it is not an element of the set. It is the capital of Hungary, but here we are talking about countries. We are not talking about the capital or the cities. If we are talking about the cities, so this will be right. It is a city in Europe, but here we are talking about country. In the example of Egypt, the country itself, it was a country, but this country is not an element or doesn't belong to A. Okay? So I hope this will be clear. Okay. So let us have other examples as well so we can make the picture clearer for you. If I have a set A, which is 1, 3, 5, and 7, and I have set B, which is 1, 2, 3, 4, 5, 6, 7, 8, and 9. So in this case, I can say that 3 is an element of or belongs to A. Is it right? Yes, I go to set A and search inside it. Do I have an element which is 3? Yes, so this is right. If I said 3 belongs to B or an element of B, is it right? Yes, because this is the set B and the 3 is in it, so it is right. If I say 9 is an element of or belongs to A, I'll see A. No, this is not A, this is B. In B, it is there, 9 is here. But in A, it is not in A. So I have to be careful which set I'm looking at the element in. So here, 9 is an element of A. So I should not go and search in B. I have to search in A. So A, only 1, 3, 5, and 7. So 9 is not. Okay. Someone said, okay, let us write in a different way. Can I say that instead of I writing 3 is an element of A, can I put it in this way? I write 3 this way. No. Why is it wrong? 3, this is set A, and this is 3. No, but 3 is not a set. 3 is not a set. This symbol or notation means subset. So 3 is a subset of A? No, 3 is not a set or subset. 3 is an element, just an element. Okay? So this is a set. These are the elements. So this is a set. These are the elements. Okay? So we cannot say that 3 is a subset of A because 3 is not a set. 3 is an element. So if I'm dealing with element compared to a set, so I have to use this symbol. So you can write 3 belongs to or element of A. But I cannot write 3 subset of A. This is wrong. So I cannot write either subset or not subset because I cannot use this notation because this notation between sets. This notation between sets only. So how can I use it? I can say that A as a set or subset is subset of B. Is it right? A is subset of B. Yes. When it happens, when I can say this. So first of all, when I use this notation, I have to make sure that this one is set and this one is another set. It is not an element to set or set to element. Both of them are sets, okay? The second thing, I have to make sure that all the elements inside the first set are included in the second set. So A subset of B. So B is the bigger. So should all the elements in it should be included here. Both of them could be equal, or B could be a bigger set which includes all the elements in A. Okay, so let us see here. In order to say that A is a subset of B, I have to make sure that A is a subset of B. I have to make sure that all the elements in A are included in B. Let us see. Here, 1 in A included in B as an element also of B. 3 is also element of B. 5 element of B. 7 elements. So all the elements in A are included in B. So A is subset. Okay, someone smarter would come and say, okay, can I say it in the other way around? B is subset of A. Is that right? No, it's wrong. Because this means that B is subset of A. All the elements in B are included in A. Are all the elements in B included in A? Can I say that? 1 is in B, and also it does exist in A. 2, no. 2 is in B, but it's not in A. So some of the element 4 also is here in B, but it's not in the A. So not all the elements of B are included in A, not all of them. So we cannot say that B is subset of A. So now we know that the set may be given in different way. So the way we describe the set, it could be different, written in different ways. Okay, so now I think it's clear now that the notation A belongs to or element of A. This means that this is an element and this is a set, to indicate that A as an individual element. Okay, A as an element, individual element of set A. I hope this is clear. So now, in order to write the set, I can write the set by listing all the elements in it. So I can say set A equals set A equals, not equals, set A. If I want to write it as a set, A, and open the bracket and say the number 1, 3, 7, 13, 19. So here in this type of sets, I'm listing down all the elements. So set A is limited to these elements. Okay, I can write them as set A, patient 1, patient 2, patient 3. I can have another set which include patient 4, 5, and 6, and so on. I have set B, drug A, drug B, drug C, drug D, and so on. Okay, so I can have group C which include 10, but group B here it includes only 4. 1, 2, 3, 4. Group C could include 10 drugs, 15 drugs, 100 drugs. So by having such way, open the parentheses or the bracket and the closing it of the sets and having comma in between, so I can list down all the elements. Just open the bracket, list down the first element, comma, second element, comma, third element, comma, and close the bracket or the parentheses. Okay? Okay. So this is one way, by listing all the elements. There is another way by just describing the property of this. So I can say set A equals group of even numbers between 10 and 20. So if I said that set A is a group of even number between 10 and 20, so this means I give already the criteria or the property of this number. So I have to go and find the elements inside this set, which should be even and should be. So it will be 10, 12, 14, 16, 18, and 20. So these are the even numbers between 10 and 20. Okay, including 10 and 20. So this I have in this case, I didn't give the elements like in here in this case or in this case, I have given the element already. but here I have given the description. Okay, so given the property that serve the criteria, or the criteria, the singular of criteria called criterion. This is singular because criteria is plural. Okay, so set A is all the patient in critical condition on the 4th floor. So here I got the criteria that they are critical condition and 4th. So I have to go and get the list and see the name Peter, Joe, Ahmad, Sarah, whoever there, and just list them. So I have already given only the criteria. Set B, I have given the drugs, all the drugs in certain experiment. So I have to go and check the type of the medicine or the drug which they are given, drug A, B, C, D, and so on. In this page, we are going to know some of the notations which we'll be using in the sets. So a set that contains no elements, empty set, empty, no elements, blank, is called empty set or null set. Null means empty, zero. And this is the notation phi. We are calling it phi. So it could be written as phi or empty parentheses, empty brackets, okay? So we can write it as 2 empty brackets or phi, okay? So phi is okay, means empty set, no elements inside it. Or 2 open brackets or parentheses and nothing inside them. These are the empty sets, okay? Okay, so the set of all elements for which there is an interest in the given discussion is called universal set. What does it mean? Universal means all the available elements, whether subject criteria is applying to them or no. For example, if I'm talking about Debrecen University, so I can say Debrecen University is our universe. So our universal set, the set which universal set, it will be Debrecen University students. If I talk about the students who are studying medicine or dentistry or pharmacist, for example, general medicine, so this will be subset of the university because this is a set of people, all the people inside the studying medicine, general medicine, they are elements in the Debrecen University set of students. So the biggest set which I have, not in the world, in my discussion, I'm talking about whom? I'm talking about the students in Debrecen University. So I cannot find any element outside the universal set, outside the Debrecen University. So if I give any number, any name, his name or her name should be found inside the set of the Debrecen University. Okay? So this is my universal. I cannot have anything outside this universal. Okay? If it is outside universal, this means it's not, I cannot apply or I cannot discuss them. Okay? Because universal set is the set of people which I'm interested to discuss on. So if I said I have the students of Debrecen, this is my universal set. So instead of having the whole universe with a planet and solar system, so I'm limiting myself to the interest of the discussion, which is universal set, which is Debrecen University. So let us do it in a nicer way. Okay, so I can say this is you, Debrecen University. Okay, student. This is my universe. I can have here faculty of medicine or medicine. I can have other faculty of pharmacy, dentistry. So this is the whole universe which I'm talking about, and these are subsets inside it. I cannot find a medical students outside this universe, or someone studying pharmacy in this university and he's outside the university. So this is my universe. So the maximum thing which I'm talking about is my universe. I cannot go beyond my universe, okay? So by having this universal set, I'm limiting myself instead of talking to the whole world to the universal set. So this is my cap, my ceiling. I cannot go beyond this. This is the universal set. Okay, I can have many subsets inside this universal set. Okay, so let us talk about this. If A, okay, this is about the equal sets. I think better to jump to this example to make it clear that we understood the universal sets. So if I said that I have my universal set is Debrecen University. So if I said I have set A, and this by definition, I did not list down all the elements, I just give definition. The first year students at medical school. Set B is all the students at medical school. All the students including first year, second year, third year, fourth year, fifth year, sixth year. So the set B, it is bigger than set A, and it includes all the elements of set A, because this is all the students in the medical school. And set A is only first year. First year is part of the medical students, of the all medical students. So how can I write it? I can write that set A, okay, is subset of, sometimes you can write it or you can write like this, okay, subset of B. Is it right? Yes, the first year students, all of them are included in the all students in medical school. So A is subset. So if I try to draw them as Venn diagram, I can write B as a big one, and this is subset, so it's been inside it, okay? Subset. So this is A and this is B, okay? So if I look at this example, I can draw the universe like this. This is the universe, which is Debrecen University. I have set B, which all the students, and inside it there is first year students of the medical sector. It should be inside it, A. I hope this one is clear, and this is my universe. Okay, so when I can say that two sets are equals, if all the elements here and all the elements here exist. So if all the elements in A and all the elements of B are the same, but could be in different order, 1, 3, 5, 7 or 7, 5, 3, 1, but the same elements, 7 and 1 and 3 and 5, so they are the same. Okay, so I can say that they're equal. So set A and B are two sets. They are equal if they contain same elements, both of them, okay? If the set A contains one or more elements of set B, and so there are two conditions. First of all, set A should have one. So the first year student should have one. And at the same time, every element in the first year is also an element of group B, set B. So if every element of set A is an element of set B, then A is said to be subset. So there are two conditions here, that all the elements here are here, but A must have one or more, 1 or 2 or 3 or 100 or thousands of elements which is common. Why they are putting this condition? Because they don't want to talk about empty sets. Because A might be an empty set. If A is an empty set, so I cannot say that, okay, A is subset of B, because I'm talking about talking the space. So here, that's why he said that it must contain one or more element. So it could be enough to read it as this, to say that if every element in the set A, okay, is an element of the set B, first year, and this in the medical school, and this all the students, so every element here is in, so this is enough. But someone, okay, will say, okay, in this year I don't have any student in the first year, so is that remains subset? No. So if this set is empty, phi, or empty set, okay, I cannot say it is subset. So subset means that it is not empty, it contains at least one or more, one or two or 100 or 1,000 or whatever element, and all of them, every element here, existing here. So in this case, I can say that A is subset of B. I hope this one is clear also.